In this 3D holographic view, we are watching a quantum wave packet travel through space toward a potential barrier. In classical physics, a particle that doesn't have enough energy to climb over a wall would simply bounce back. Crossing the barrier would be impossible. But quantum mechanics works very differently, because particles behave not only as solid points, but also as waves spread out in space. As this wave packet reaches the barrier, part of it reflects, just like a classical particle would, but another part leaks through, appearing on the far side even though it doesn't carry enough energy to overcome the barrier. This phenomenon is known as quantum tunneling. The barrier is still higher than the particle's energy, yet the laws of quantum mechanics give a small but non-zero probability of finding the particle beyond it. And this isn't just a weird theoretical idea. Tunneling is a real physical effect that helps power nuclear fusion inside stars, and it forms the basis of modern technologies like tunnel diodes and scanning tunneling microscopes. What you're seeing here is one of the most mind-bending behaviors of the quantum world, visualized in 3D.